Hey guys, Mr. Thibodeau here. So, going on for lesson 10, rational numbers and equivalent fractions. So, lesson 10, rational numbers. All right, so I want you guys to do your mental math. I want you to do your problem solving. I'll tell you ahead of time that while the rational numbers is sort of easy, this is a little complicated stuff here, okay? So, they're trying to explain it this way. You can read through here. I encourage you to do that. Maybe that'll help. I'm going to explain it a different way. Okay. So, whole numbers are like 0, 1, 2, 3, 4, etc. Okay. Then we have integers, which are negative numbers and whole numbers. Okay. All whole numbers are integers. All integers are not whole numbers because negative numbers are not considered whole. Okay. Now the next step is rational numbers. And that includes many fractions. Okay. A rational number is a number that can be set. Rational numbers include fractions, essentially. Okay. So fractions, negative numbers, and whole numbers. Now, I want to check something real quick because I'm pretty sure. So I think rational numbers can be a fraction. So this says 5/3 here. Now, negative 5/3, in fact, is a rational number. Now, that's a rational number. If I try to solve it, if I try to turn it into a decimal, I am going to get a repeating decimal, okay? Point 6666666666666 going on forever, okay? That, the 0.6 repeating, that is actually an irrational number, okay? So if I turn it, so some decimals and some notations are irrational. They go on forever. So pi 3.14 ... that is an irrational number. E is an irrational number. And E is a notation you'll probably never come up across, but unless you go really into math. But and then 0.333 repeating, those are irrational numbers. However, 1/3 is a rational number. Okay, so when you that's why we leave things in fractions, is because we don't create for ourselves an irrational number. All right. The next step is equivalent fractions. Man, this is really struggling today. So equivalent fractions, the thing about them is that they're the same no matter how we do it. So 1/2 is the same as 2/4, is the same as 3/6, is the same as 4/8, which is the same as 8/16, which is the same as 16/32. Okay. And as long as you're multiplying the top and the bottom by the same number, you will get an equivalent fraction. And the reason you do that is so that you can add and subtract fractions from one another, okay? Which I'm sure they'll get to probably in the next chapter, I assume. No, they're doing percents. Okay, well, the book will get to it when it gets to it. It sometimes confuses me how it bounces around, but it usually makes sense in the latest sense eventually. So the greatest common factor is the largest whole number that is a factor of every number in the set. Okay, we're going to use that a lot. The greatest common factor is exactly what it says. So a number that is a factor that is shared between two other numbers those are common factors. So for 1 and 16, okay, the greatest common, we have 2, 8, we have 3, and then we have 4. Okay. Now for 24, we have 1 and 24, we have 2 and 12, we have 3 and 8, we have 4 and 6. The greatest common factor is right here. Okay, it's the biggest number that goes into both 16 and 24. 4 and 2, so these are common factors. And then this is the greatest common factor. Okay. All right, so now let's go ahead. Oh, so it does talk about improper fractions. So improper fractions are still rational numbers. That can be confusing, okay? So improper fractions are still rational, but they can be simplified or I would say are top-heavy. That's how I like to describe them, because the top is bigger or equal to the bottom. Okay, so 5 over 2, that is an improper fraction. There's still math that you can do for there. Okay, 4 fourths, again, why are you writing that instead of just 1? So that's an improper fraction. Now, there are times in which we create improper fractions because we're going to use it immediately for math, but generally we don't want to just leave it as an improper fraction. It's not helpful for us. Okay. A mixed number is a whole number plus a fraction. So usually we turn improper fractions into mixed numbers. So 5 over 2 is improper. 2.5 is proper and a mixed number. Okay. So the practice set, I want you to do those, and then the work I want you to do is going to be 1 through 10 and 19 through 29 odd. Okay? So the written practice is 1 through 10 and 19 through 29 odd. Okay? All right, guys. Have a good one.